In this video, I am going to show you how to create an interactive normal distribution graph where you can input whatever mean and standard deviation you like, and that will be superimposed upon a standard normal distribution graph. So we're going to start off by creating a column of Z-scores. Now remember, the Z-score is a number of standard deviations from the mean. When we're working with a normal probability distribution, we know that according to the empirical rule that 99.7% of the data is within 3 standard deviations of the mean. So we're going to use Z-scores from -3 to +3 because that will give us 99.7% of the data and create a nice looking graph. So we're going to start with the smallest Z-score of -3, and then we need to increment this up until we get to +3, and a nice increment will be 0.1. So I'm going to create a formula so I can copy the formula down until I get to +3, and I'll do that by going equals, click on cell A2 that contains the -3, then type in plus 0.1, and when you hit enter, you see there's the -2.9. Click back on that cell A3, point your cursor to the bottom right of the cell until it becomes a little plus sign, and then left click and drag until you get a score of +3, which should be around cell 62. Yeah, there it is. See, there's the +3. So now we have the Z-scores from -3 to +3. We're going to first construct a graph for the standard normal distribution, and there is a built-in formula in Excel which looks like norm.s.dist. So we're going to create a norm.s.dist column, and then from this column we will create our graph. So go to Formulas, More, Statistical, and scroll down until you get to norm.s.dist. Notice it's in alphabetical order. There's norm.s.dist. Click on it, and notice that all we need is a Z-score and whether we want the formula to be cumulative. The Z-score we have in column A, and so we're going to click on the first Z-score, the -3, which is in cell A2, so that when we copy this formula, it will simply change the designation, the row designation, as we copy it down. Cumulative is actually going to be set to false. That means it is going to just be a single point that will be graphed on the curve. We only use cumulative set equal to false when we want to create a graph using the Normdist. If we want to find probabilities, we always set cumulative equal to true. So now click OK, and you get this number here, 0.0044, and we are again going to copy this formula all the way down to row 62. So bottom right, little positive sign, left click, drag down to row 62, and there we go. Now, since we copied this, that column is already highlighted, so just keep it highlighted, and we are going to insert a line graph. We want I am going to just do a 2D line graph where I want the lines drawn that connect the points, but I don't want the points to show. So this first option here under 2D line. So I click on that, and here's the default graph from Excel. Now notice that the vertical axis is just like we'd like, but the curve is labeled in blue and it's called Series 1. I would like this curve to be called Norm.s.dist. So what I'm going to do is, here notice that says Chart Tools, and on this left side you see Design. If you click on Design, you will see over here a Select Data box. If we click Select Data, on the left side of here in this pop-up box, you see it says Series 1. Click on Series 1 and then click the Edit button, and for series name we will click on the cell A1 which says Norm.s.dist, And now when you click OK, notice down here you can see on the graph it's changed the labeling here in the legend to Normdist. And then don't click OK again though, because we're going to do something else. Notice that down here is just a default labeling of the horizontal axis starting at 1. We're going to label our horizontal axis with the Z-scores right now. So you're going to click Edit, and then we get this Axis Labels box. So notice I clicked the Edit on the right hand side this time, and I'm going to highlight cells from A2 down to A62. There we go. Click OK. Alright, click OK. Let's go up to see my graph. There, and we can see now that the graph is labeled from -3 to +3 on the horizontal. Now if you look at, if you change the size of your graph, it'll change the labeling on the horizontal axis. Kind of the scale will change. So if I point down here where I get this double-sided white arrow, and I left click and drag it, it will change the size of the graph. Notice if I do it over here, same thing. If I stretch it horizontally. Now notice where 0 is, it has this scientific notation, 1.5 e minus 15, so it's kind of a rounded off version of 0. In order to fix that, what we can do is we go to our Z column and go to that cell where it's here, it's A32, go to the cell with the 1.5 e negative 15, bring down your toolbox, and what we're going to do is go to, in the Home tab, you go to the Number Tools, and we are going to change that format to number right here, right? And see we get 0.00. I want it to have the same number of decimal places as everything else, which means 1 decimal place. So here, these are the buttons that will either increase or decrease decimals. So we'll decrease it down to 0.0. And now, when we look at our curve, we have the 0.0 labeled there, and it doesn't have that funny scientific notation designation in there, which doesn't look good, and it's a rounded version. Alright, I'm going to shrink my graph. Whoops, let me undo that. I'm going to shrink my graph here so that we can see my other columns. Let's click in here. Alright, let's try this side. Alright, so let me shrink the graph and move it aside. Okay, so here then is a graph for the Normdist distribution, the standard normal distribution. I'm going to change my title though. So notice how I click in the title, and I'm just going to type over it normal distribution. Okay, and up here where I typed it in this text bar, it's typed in. Once I hit enter, it'll put it in here. Okay, if you don't want normal distribution, we could also do PDF, or probability density function, so we could use that title if you prefer. Alright, so here is then the standard normal. We want to now create an interactive normal distribution given whatever mean and standard deviation we choose. Recall that for a standard normal, the mean, which is the middle of the curve, is 0, and the standard deviation is 1. We are going to be able to choose whatever mean and standard deviation we desire. So I will type here in cell C1 mean, and then we will enter that into cell D1, and I'm going to highlight that with yellow to show I want to input it there. And we will input a standard deviation right next to it, and I'll highlight that in yellow. So these are the input cells. D1 and D2 are the input cells. Now, in order to create a non-standard normal distribution for some given mean and standard deviation, we are going to be using a formula called Normdist. Notice it's lacking the S in the formula, which was for the standard normal. We're going to need a mean and standard deviation to start with. So let's go ahead and use a mean of 100 and a standard deviation of 15 as our default to begin. This happens to be the mean and standard deviation for IQ scores, for standardized IQ tests. Alright, now what we need to do is create a cell for our random variable. When you're doing the standard normal, your random variable is z. We are going to be doing a non-standard normal, so the random variable is x. Actually, I am going to cut and paste the Normdist column and put it in column F, and then in column E I am going to put my random variable x. That'll be more convenient. Okay, so remember that we are creating a normal curve where the z-scores go from -3 to 3. We need to convert that z-score to an x-score. Remember that the relationship between z and x is z equals parenthesis x minus the mean close parenthesis divided by the standard deviation. So if we want to algebraically solve this for x, what you end up with is z times the standard deviation, because notice z tells you the number of standard deviations. If you multiply that by the value of the standard deviation, then you actually have a unit in the same, you get a measurement in the same units as our variable x here. Then we need to add the mean, so plus the mean. So here, this is a formula that we're going to use for our x column. X equals z times the standard deviation plus the mean, where the standard deviation is in cell D2 and the mean is in cell D1. So let's do our formula in our column E, row 2, and we'll be able to copy this formula. So we're going to create a formula. Notice the z-score is going to be changing, so I'm going to click on the z-score -3, and then I want to multiply that by the standard deviation that is input in cell D2. So I'm going to click on D2. Now when I copy this formula, I want the z-score to change according to the row. So instead of A2, when I move down to row 3, it'll be A3. When I move to row 4, it will be A4, and so on. However, I do not want the cell designation D2 to change. It should always stay D2 because the standard deviation is the same for every single cell here. So what I need to do is fix this or make it a constant, and the quick way to do that is to simply press F4. Some computers, keyboards, you can just hit F4 directly. Some computer keyboards you will have to hit your function key and then hit the F4. And notice we get then $ in front of the column and row designations respectively. We get a $ in front of the D, we get a $ in front of the 2. Whenever you have $ in front of a row or column designation in Excel, it fixes that row or column, makes it a constant, so that when you copy the formula it won't change. So we have our z-score in cell A2 times our standard deviation in cell D2, which is then fixed, plus we want to add the mean, which is in cell D1. Again, when we copy this formula, we do not want the mean to change. We want to keep that same D1 designation, so you're going to put the $ in front by using your F4. And now we have z times standard deviation plus mean. Hit enter, and this then is the x that corresponds to 3 standard deviations below the mean. I want to copy this all the way for the x for 3 standard deviations above the mean, so that means all the way down to, again, row 62. So left click and drag to row 62, and that takes us up to 145. Alright, so remember the mean is 100, standard deviation is 15. Right? 3 standard deviations above the mean is 15 times 3, which is 45. Add it to the 100, we get our 145. So that looks good. So here are the x scores. Now that we have a random variable x, we are ready to find or create our Normdist column using the Normdist formula. So go to Formulas, More, Statistical, scroll down to Normdist. Okay, this time not NormSdist, but just norm.dist. And now we need to enter our x, our random variable, the mean, the standard deviation, and again we'll set cumulative to false. So let's move this down. For x, that will change. So I'm creating a formula, and I will click on the first x here that's in E2. That we want to change as we copy the formula. Now click on the mean. We do not want that to change. So click on the mean and then do your function F4 again. Okay, for the mean, click in standard deviation, click on the standard deviation, function F4 again. So fix these cells so they don't change when we copy. Cumulative is false when we're creating graphs. Click OK. And now we are going to copy this down to row 62. So there we go, all the way down to row 62. Again, once we copy, everything's already highlighted. So now we will go to back to our curve here. Oh, I'm going to have to actually click in it and it'll unhighlight. Click on Design, and we want to superimpose our our non-standard normal on top of our standard normal graph. So what we're going to do here, let me first get the graph so we can see it. I want to make it a little bigger here, stretch it out. I'm going to go to Select Data, and then over here on the left hand side I'm going to add an entry or a series. I'm going to add the Normdist. So the series name is Normdist. Then I click into series values. Make sure you delete what is already in there. And now you're going to highlight from F2 down to F62. Okay, click OK. Right, so see we've added the Normdist series here. Now our horizontal axis has changed. It's defaulted back to starting at 1. And here you have a choice. You can either have it labeled with Z-scores, or you can have it labeled with your new X values. I'm going to have it labeled with the new X values. So I am going to edit. I have to scroll back up here, and I'm going to highlight my X values from E2 all the way down to E62. There we go. Click OK. See, notice now our horizontal axis starts at 55 and continues on. If we click OK, now when we look at our graph over here, we see now in red we have our Normdist, right? And look how flat it is. And that's because it has a standard deviation of 15, which was a lot bigger than that standard deviation of 1. So here we can play with our standard deviations. That's why it's nice to have the interactive graph. It's really the standard deviations that affect the shape of the graph. Notice that the mean is always going to be right here in the middle. So whatever mean you get, it will be right in the middle, corresponding to the z-score of 0. But how big this is totally depends on the inputted standard deviation. I am going to close that out. I am going to move this over here so we can see it below our input for mean and standard deviation. I think I'm going to highlight this as well. So let me go to Home and Highlight. So we're going to have mean and standard deviation here highlighted. And notice what happens as I change the standard deviation. So right now the standard deviation is 15. We have this very flat curve because remember, the standard deviation is a measure of the spread of your data. This is really spread out, so it's really low and skinny. Let's decrease this a bit so it's a little less spread out. Let's give it a 10. So we change it to 10, enter, and notice how it's bumped up a bit. Alright, let's decrease it again. Let's change it to 5. Now watch this. Okay, it's bumped up again. Alright, let's see what happens when we do it to 1. And then notice it's exactly the same as the standard normal, right? Standard deviation of 1. The only difference is the horizontal labeling because we have a 100 here. Let's see. Oh, notice I have decimals there. I actually don't like that. So I'm going to go to my X column here. And have to move this out of the way so we can see it. I'm going to go to this X column. I'm going to highlight it. And actually, I better not change it. It rounded it off as it sees appropriate. If you wanted to change the decimals, notice if I want them all to have one decimal place, so that 98 is 98.0, then I can go to home, and again on the number formulas here, Mint tab, I will increase it up to 1, so now that they're all 1. So now when I look at this, here we go. Okay, they all have the same decimal, so I like that better. Okay, now let's change the standard deviation to something even less than 1. So 0.5, and now watch what happens to the curve. Right? Think about what's happening. We noticed how every time we decreased the standard deviation or the spread of the data, it got a little narrower and steeper. Bigger standard deviations flat and wide, smaller standard deviations narrow, skinny, tall. So let's change it to 0.5, and you now will see that the Normdist will jump above the Normdist. It'll be, so the red will be above the blue, right? And there we go. And look at quite a difference here with that 0.5. So this now is our Normdist with the standard deviation of 0.5. This is our standard normal with the standard deviation of 1. It's a big difference there. Let's see. Let's go down even further. Let's have this again to 0.025. All right. And now look, this standard normal, this non-standard normal with the standard deviation of 0.025 is so skinny compared to the standard normal with the standard deviation of 1 that the standard normal is almost a flat line down here compared to it. So that's pretty interesting here. So here, this will give you a better understanding of the standard deviation, how it affects the graph. Okay, how big standard deviations, or make it flat and wide, small standard deviations, tall and thin. Remember these two, a standard normal and the non-standard normal, relative to each other. So the blue one is going to change relative to the red one to fit into the graph as however you've scaled it. Alright, so I hope that was helpful and that you can use this to create your own interactive graph using Excel 2010.